All right, so here we're trying to create a transition probability matrix for this game that we already looked at. Just as a quick review, we had two unpainted ping pong balls. We would put them in a jar, and then we would take one in each round of the game. We would take one randomly. If it's unpainted, we flip a coin. If it's head, we paint it red, and if it's tail, we paint it blue. A red, blue, and then we put it back. That's one round, and then we keep doing that. But if the ball that we take out randomly, because after the first round one of them is going to be painted, if it's painted, we paint it the other color. If it's red, we paint it blue. We don't flip a coin. If it's blue, we paint it red. All right, so, and we tried to use a triple to show the state of the system, which is, or this game, which is the composition of the balls that we have in the jar in each round, in the beginning of each round, which is basically how many unpainted balls you have, how many red, how many blue. So we use this triple unpainted red, blue to show how many balls of each color we have. And so we're gonna have, how many states are we gonna have? We're gonna have 0, 1, 1, 0, 2, 0, and so forth. We have 6 states, and so our transition probability matrix P is going to be 6 by 6. Now I'm trying to find the probability of each one of these PIJs basically. PIJ is the probability of going from a state I to a state J. For example, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So P, I want to find P1. So let's say P3, 1 here. P3, 1, which means if I'm here, what's the probability that I end up here? P3, 1. What is this probability? To find that, I should ask myself this question. What should happen so that I go from 2 blue to 1 blue, 1 red? If you review the rules of the game, you take one ball out, it's going to be blue for sure. The rule of the game is that you have to paint it red and put it back. So you will for sure end up in 0, 1, 1. So that probability is 1 because it happens for sure. And then because the sum of each row is 1, you don't even need to think about the rest. The rest are going to be 0. Let's find out the probability of, let's say, this one. 1, 1 to 2, 0. So what it means, if I'm here, what's the probability that I end up here? So what does it mean, 0, 1, 1? It means in the jar I have 1 red, 1 blue. Okay, so I take one randomly. There's a 50% chance it's going to be red, 50% chance it's going to be blue. And then where I'm going is both red. So what should happen? So I go from 1 blue, 1 red to 2 reds. I have to pick the blue one, and once I do that, I'll definitely paint it the other color, red, put it back. Then I will be I'll end up with 2 reds. So what should happen? I should take the blue one when I pick one randomly. What's the probability of that happening? 50% chance, or half. How about P11? P11, going from red blue to blue red blue again. That's 0 because you'll take one, you'll paint it, and you're gonna end up either in blue blue or red red. So this is also 1/2. The rest of them are 0. Okay, the only tricky one I guess here is going from, which is P6 2, going from 1 unpainted, 1 blue to 2 reds. What is that? What should happen? Is it even possible for that to happen in one round of the game? So remember that transition probability matrix talks about one round. There are ways that you, I mean, it's possible that you have one unpainted, one red to end up at some point in the future with two reds, but not in one step. All right, you already have one blue. You take them out. If it's blue, you paint it red, put it back. Now you have one unpainted, one red, not two reds. If you pick the unpainted one and you're lucky and you flip the coin, you get head. Then you're gonna have again at best one red, one blue. So that probability is 0. How about P63, which is going from one unpainted, one blue to two blues. So for that to happen, you have to pick you should be lucky to pick the unpainted one, and you should be lucky to, when you flip the coin, you get tail, so that you paint it blue, and when you put it back, you're gonna have two blue things. So two things should happen. You should pick the blue one, what's the unpainted one, the probability that is half, and I multiply. When you flip the coin, you should get the tail. So that probability is 1/4. All right, you can use this, follow the same logic to find all the other probabilities. I'm going to maybe pause the video now, try to calculate them all, and then check with this answer that I'm going to show now. Let me erase this so you can see this better. All right, that's it.